We've added the inverse trig functions to our suite of functions, if you like, that we look at. We've looked at logs and exponentials and trig functions and also. So inverse trig really is the last main type of function we need to look at. So of course we need to know how to differentiate it, how to integrate. So let's take a look at it. So y equals inverse sine of x. How are we going to differentiate this? Well, obviously at this stage we don't know. So I'm going to rewrite this. I'm going to make x the subject because we do know how to differentiate the sign. So if I, instead of finding the derivative of y with respect to x, I find the derivative of x with respect to y. Differentiate sine, we know it goes to cosine. So that's dx to y. dy dx, therefore, is 1 over the cos of y. So there's our derivative. The only problem is it's in terms of y. I mean, it's not that big a deal. It just means substituting the y value instead of the x value. But it would look nicer if it was in terms of x. So a little bit of rearrangement, we can do it. I'm going to change cos y to be the square root of cos squared. And then the cos squared I can change to 1 minus sine squared. But we said x was equal to sine y. So I can now say that's 1 over the square root of 1 minus x squared. So I've got it in terms of x. All right, let's have a look at inverse cos. We'll do a similar thing. Make x the subject. Differentiate that. Cos, of course, goes to minus sine. And we get minus 1 over sine y. I'm going to do the same thing. I'm going to change the sine y to be the square root of sine squared. Sine squared I can change to 1 minus cos squared. And in this case, we said cos was going to be x. So I get negative 1 over the square root of 1 minus x squared. So inverse sine differentiates to give me positive 1 on the square root of 1 minus x squared. Inverse cos, negative 1. I guess that's sort of similar. We can remember that because differentiate sine, it goes to cos. Differentiate cos, it goes to negative sine. So in both cases, it's the cos that's going to the negative. Let's have a look at tan, or inverse tan. Change that one, we get x equals tan y. Differentiate tan, we get sec squared. So turn it upside down, 1 over sec squared. This time I don't have to square the denominator, it already is. Sec squared is, of course, 1 plus tan squared. And so there's no square root sign with this one, and it's 1 plus x squared. All right, to generalise those. If it's a linear function, so x over a, then differentiate it, it'll become 1 over the square root of a squared minus x squared. Inverse cos, minus 1 over the square root of a squared minus x squared. And inverse tan will be, now this is where the difference is. Notice on the top, it's not 1, it's a. So a over a squared plus x squared. Personally, I remember them this way. If it's the inverse sine of any function, so it doesn't matter whether it's linear or not, then it's the derivative over the square root of 1 minus the function squared. Inverse cos minus the derivative over the square root of 1 minus the function squared. And inverse tan, the derivative over 1 plus function x squared. Now remembering that way, I don't have this problem of remembering, inverse tan has a, the others don't have a, because all of these have the derivative on top. So it is consistent with all three. So derivative over 1 plus function x squared for inverse tan. Let's do a few. Inverse sine of 5x. Bingo. That's the advantage, I guess, of knowing it as derivative, because derivative of 5x is 5 over the square root of 1 minus the function squared. Well, 5x squared is 25x squared. So I got the answer straight away. Had I used the other one, a would have been 1/5. So I would have ended up with 1 over the square root of 1 on 25 minus x squared. And then I've got a fraction on a fraction. I would have had to tidy that up. It is minus the derivative, which in this case is e to the x. What's the easiest derivative? Over the square root of 1 minus the function squared. Square e to the x, we get e to the 2x. Here's where I guess that x on a formula is useful, because it is in the form of x on a. So in that case, I could go, it's 1 over the square root of a squared minus x squared. If I did it the way I just tend to remember it, to be honest, this is how I would do it, is I would end up going, 1/3 over the square root of 1 minus x squared on 9. But there actually is a common denominator there, because remember that 9 is under the square root sign. So I can just multiply top and bottom by 3, and I end up with 1 on the square root of 9 minus x squared. E to the power of inverse cos x. So we did inverse cos of e to the power of x. Now it's e to the power of inverse cos x. So it actually is an exponential we're differentiating. An exponential, we differentiated the power, put it at the front. The power in this case is the inverse cos function. So differentiate the inverse cos function. I get minus 1 on the square root of 1 minus x squared times by e. The power doesn't change. I might just tidy that up and put it all into one fraction. So there we go. Minus e to the inverse cos x over the square root of 1 minus x squared. Chain rule. So notice we don't write it as tan negative 3, okay? Because inverse tan negative 1 has a different meaning. So in this case we write it as inverse tan x all cubed. Anarchy. Bring down the power, lower the power. Diff the inside. Inside in this case is inverse tan, so we get 1 on 1 plus x squared. Tidying that one up, there we go. 3 lots of inverse tan x all squared over 1 plus x squared. Ooh, product rule. X squared inverse tan x cubed. Write down the first, x squared. Diff the second. The second is an inverse tan function. Inverse tan is derivative 3x squared over 1 plus the function squared, x cubed squared, x to the power of 6. Plus, write down the second, inverse tan x cubed. Diff the first. X squared becomes 2x. Now, a little bit of tidying up to do. Yeah, I didn't bother making that all one fraction. That's left it like that. So 3x to the 4 on 1 plus x to the 6. Plus 2x inverse tan x cubed. How good is that? Are we having fun yet or what? Well, it's time for you to have fun then. 1D.